Okay, let's take another small example, and I've filled in the patterns because they're going to be the same. If we want to print an expression out, well, we can already print an expression out because we derived show. But when we derive show, we get the sort of dumb representation that we've defined up here, so that expressions will look like that. What if we want to print them so that they look more like this instead? Well, let's define a function to do that, a function for turning an expression into a nice string. So the number n, what should we convert that to? Just n on its own? Is that right? It needs to be a string. So we have a function for turning integers into strings, and that's the show function. If we want to do the add expression, we can recursively show the sub-expressions E1 and the sub-expression E2, and we want to turn them into one big string, and we can do that by appending the plus operation, or rather how the plus operation should look there. And we're going to do something, again, cut and paste, there it goes. We're going to do something very similar for times. Okay. Let's have a look at that. Example 2, and we can show x example 2. Does that look right? No, example 1 and example 2 come out the same way. So what have we done wrong? Well, we've forgotten to take into account the precedence of the operators, right? We need to put brackets in. So where do we put brackets in? Well, we could be on the safe side and just put brackets everywhere. So we could put a bracket there, and there, there, and there. We could do that, but then we'd end up putting too many brackets in, right? So where do we actually need brackets? Well, let's just have a look. Let's just have a think for a second. Where do we actually need brackets? Which of these expressions needs its parentheses, its brackets? This one doesn't, right? What about this one? No, because the precedence of multiplication binds it more tightly. But this one does, okay? So what's the general rule when you need the brackets? You only ever need to bracket something which is inside a multiplication. That's the first thing. The second thing is that the only things we need to bracket are additions inside multiplications. A multiplication inside a multiplication doesn't need brackets. It's only an addition inside of brackets. So we need to think when we have an addition inside of brackets. When we have a factor, which is an addition, we must have a bracket around it. Okay, so that's what it says. All right. So how are we going to do this? Well, it's we only ever need to bracket inside a multiplication. So we might need to put brackets around this one, and we might need to put brackets around this one. Okay, so I'm going to make a function that maybe puts brackets around that. I'm going to call it factor. The components of a product are called factors. I'm going to make this a show factor. So showing a factor, if it's an add expression, then we need to put brackets in, right? So we need a left bracket, and we're going to need something, and then a right bracket. And what are we going to show in the middle? Yeah, we can use a show x. We can actually just use the function we defined up there. So we go back to showing an expression. Otherwise, how do we show a factor for any other expression, e? Well, we showed it just as a normal expression. Shall we just also go show expression of e? So all we've done is say, if there's an add expression, we put in the extra brackets. Otherwise, we do exactly as we did before. Let's just compile that. Compiles, that's good. Let's just try our expression 2 and expression 1. And indeed, we get the brackets that we hoped for in expression 1. Let me just eval those things and just to make sure we get what we expected. Yes, indeed. Any questions? Yes, a question.
Show factor in the multiplication calls show expression.
Yes.
And then show expression in the multiplication calls show factor again. Doesn't it become like a circle thing?
It doesn't become circular because we show an expression on an addition. And the rule for showing an expression on an addition always applies the recursion to a smaller expression. So a circle, an evil circle is where you would have a recursion where the argument was not getting any smaller or where you're not actually producing any output. But in this case, the argument will always get smaller. So each recursive call, this is the only recursive call when we call show factor calls show expression, which doesn't apply it to a smaller argument, but then show expression on an addition will always shrink these and apply it recursively to the smaller arguments.
So this row takes a small argument, the row under the row below. Yeah.
This one takes anything which is not an add, but the same reasoning applies, is that in the next step, when we show this expression, we'll be applying the recursion to a smaller sub-expression. The easiest way to see it, and it's a little bit long-handed, is you write down a concrete example and the function, and then you just take a series of computation steps by replacing occurrences of left-hand sides with occurrences of right-hand sides. And it doesn't matter what order you will do it in, if you get to an answer, that's the answer that the Haskell interpreter will find. Okay? So the computation mechanism can be thought of very simply, just replace left-hand sides of definitions by right-hand sides.